Liftoff. Liftoff. 30 minutes after the
A star like our Sun is born from clouds of hot gas and dust left behind when another star dies. As the cloud cools, it collapses into a spinning disk of particles bound by gravity. The particles in the center of the disk are packed so tightly together that friction causes them to heat up and glow. A protostar is formed. As the protostar gathers more mass, the atoms in its center fuse together in a nuclear reaction. A powerful blast of energy is released, igniting the nuclear furnace that will power the star throughout its life. A medium-sized star like our Sun has enough hydrogen fuel to live for billions of years, but eventually, like all stars, it will run out. Near the end of its life, as its hydrogen supply dwindles, a final burst of energy will cause its outer layers to expand hundreds of times its original size. Our Sun will become a red giant. As the red giant uses up the last of its fuel, it will cast off its outer layers. Reduced to a brightly glowing core called a white dwarf, it will spend its remaining days slowly shrinking and cooling until it finally burns out. If a star is several times more massive than our Sun, it may end its life in a gigantic explosion called a supernova. The stardust and gases that it leaves behind may eventually form another star, and the cycle will begin again. A star many times more massive than our Sun may end up in an entirely different form. The extreme gravitational pull at the core of a supermassive star might cause it to collapse to a point of infinite density. It may become a black hole, pulling all matter around it toward its center, a hole so dense that not even light can escape its pull. A poet once wrote that every atom that belongs to me as good belongs to you. And it is true that we are all made of the same stuff. We share our atoms with the stars, where most of the elements originate. Stars like our Sun continue to generate matter in the form of plasma, the lifeblood of the universe. Plasmas conduct electricity and are strongly influenced by magnetic fields. On Earth, we see plasma in the form of lightning. Elsewhere in the universe, it assumes different forms. The Sun is a dense ball of plasma. Its rotation causes the plasma to generate powerful currents of electricity, which in turn create magnetic field lines. As the solar dynamo turns and churns, the field lines twist and tangle. A magnetic field line may poke through the surface in a gigantic loop. The bases of the loop become areas of concentrated magnetic force called sunspots. Sunspots usually appear in pairs, one a north pole where a field line emerges, the other a south pole where a field line returns. Great tubes of plasma called solar prominences leap from one sunspot to the other, following the path of the magnetic field lines. Sometimes these tubes break, and plasma is ejected into space in a solar flare. Even more plasma is unleashed by the solar wind. This cosmic current of electricity has a dramatic effect on Earth. Like the Sun, Earth has a strong magnetic field. If Earth was in a perfect vacuum, its magnetic field would look much like that of a simple bar magnet. But the force of the solar wind alters its shape. As the solar wind strikes Earth's day side, the magnetic field is compressed into the shape of a bullet. On the night side, it is stretched into a long tail. This comet-shaped region of space is called the magnetosphere. As the solar wind flows past the magnetosphere, it generates an electrical current. Some of the electrical current flows down along magnetic field lines in the polar regions. If these currents are strong enough, the atmosphere will begin to glow, an effect called the aurora. An aurora is a natural neon light show. A neon light is a gas-filled tube with two electrodes on either end. When a current is applied, the gas inside the tube becomes a plasma. It releases energy and light. Pure neon glows reddish-orange. A combination of other elements creates different colors. Mercury, for example, causes the light to glow bright blue. Elements in Earth's upper atmosphere likewise determine the color of an aurora. Oxygen atoms glow a whitish green, nitrogen a deep crimson. Auroras are especially prominent when the sun is active. A solar flare can cause a strong gust of plasma to strike the magnetosphere and generate an aurora. These solar power surges can also create magnetic storms. During a magnetic storm, radio communications may be disrupted, electrical power transmitters can be damaged, and Earth-orbiting satellites may receive large doses of harmful radiation. In 1979, Skylab tumbled to Earth prematurely because of the sun's activity. Intense solar wind heated and expanded the upper atmosphere and increased drag on the spacecraft. Its orbit decayed, and the friction of Skylab's rapid descent turned it into a blazing ball of fire. Solar activity has since become a critical factor in the design of spacecraft. Earth benefits from its relationship to the sun, but without the shields of our atmosphere and magnetosphere, it would be as desolate as a distant moon. The Voyager space probes were sent out to investigate the outer planets in our solar system. One day, they will leave the solar system altogether and journey into unfamiliar territory. In the meantime, they have made several important discoveries. Some planets in our solar system have magnetic fields, others do not. Jupiter's magnetic field is shaped much like Earth's. But the field lines of Uranus are wildly askew, probably because the planet is tilted on its side. But the solar wind blows against all the planets. It forms a huge bubble in space known as the heliosphere. This is the domain of our sun, the solar sea. The heliosphere has a boundary where the solar wind stops. Scientists wait for the day when the Voyagers will cross that boundary and tell us what lies on the other side of the solar sea.
Please select a question. Are there other planets besides those in our solar system? Choose an expert for an answer to this question.
There certainly is a lot of growing evidence that planetary systems are more common than we may have thought before. Just consider the varieties of moons around the planets that are in our solar system and the great varieties among the planets. We certainly think that the probability is quite high that around 50% of the near sun-like stars probably will have some planets around them.
Is there life anywhere else in the universe?
That, to me, is the most exciting scientific question I know. Are we alone? So far, we have no evidence, scientific evidence, that there are other intelligences elsewhere. But there must be. There can't have just been this one miracle here on Earth, which formed in a rather average planet around an average star under average conditions. So as a geologist, I feel strongly that life is a natural process of evolution, geologically and biologically, and therefore I think there must be living entities elsewhere in the universe. I hope in my lifetime we'll discover that fact.
What is the biggest misconception about space?
I think one of the big misconceptions about space is the degree of difficulty that has to be mastered to successfully put people or equipment into the space environment to conduct a complex mission. We make it look very simple on television. It's extremely difficult in real life, and it takes a particular level of skill and discipline to master it.
How are our views of Earth and space changing?
We're beginning to understand that Earth is really one of many planets, and that we compare ourselves among the other planets and learn a great deal. The volcanoes on Io, the atmosphere of Venus, and the possibility of a greenhouse effect there teaching us about the greenhouse effect on Earth, the dust storms on Mars. From all of these things we look at elsewhere in the solar system, we realize that our planet has a number of processes on it that are just typical, and that we need to cope with them by studying them comparatively with other planets. At the same time, we learn that our planet is a single unit. It is not just a group of nations trying to get along, but it is a single unit that we must take care of as a single unit. And we see this perspective from space, both scientifically as we study all of these interesting processes, and culturally as we reach out internationally to try and accomplish these objectives together.
What is your favorite celestial body?
Well, it's hard to have a favorite planet or star or comet or asteroid. It's kind of like asking a parent what is their favorite child. We have to pick among very interesting and diverse regions. Even on Earth, we have to pick about our favorite city. We might have interesting and diverse reasons for picking one city at one time and another city at another time. Mars is the only other planet with air and water in our solar system. And in that sense, it is the one place that stands out for human investigation, for humans to go there and possibly even someday to settle there. That's why Mars stands out in such a special way. But of course, Venus is interesting, Jupiter is interesting, the moons of Jupiter, Ganymede, Io, Callisto, everywhere in the solar system is a wonder to explore and a wonder to behold.
Well, Mars has to win hands down as the planet of choice for a geologist with an interest in volcanoes. I'd love dearly to land on Tharsis or Elysium and explore the immense volcanoes that are there. As an Earth explorer, the Southern Cross has always intrigued me most. Its particular place in everything from history to travel lore to song as a dramatic symbol of exploring the vast oceans of our own planet really is very compelling, and it looks great from orbit.
That's an easy one. For me, it's planet Mars. Mars is a geologist's paradise. It's got as much land area as the surface of the Earth. It's a mysterious planet with all kinds of features and processes we don't understand. And most important, it's the only planet that humans might be able to go to and survive for a long period of time.
I guess like so many other people, my favorite planet would be that one that we haven't visited yet that's most Earth-like, and that's the planet Mars. Because I had thought a few years ago that we might be visiting there in the relatively near future, my license plate says Mars Guy. I'm afraid that we just may not get to Mars within my lifetime. Maybe we'll be fortunate to get back to the moon.
Apollo 11 landed on the moon on July 20th, 1969, ushering in a new age in space exploration. 20 years were to pass before the next ambitious goal in space travel would be declared.
I believe that before Apollo celebrates the 50th anniversary of its landing on the moon, the American flag should be planted on Mars.
Although some experts now say that the goal of sending humans to Mars by the year 2019 is optimistic, most agree that a touchdown on Mars sometime in the early part of the 21st century is within reach. What will it take to land on Mars? Who will go? How much will it cost? What do we hope to learn? This section will explore possible plans for a Mars mission and address many of the critical questions to be answered before we can leave human footprints on Mars.